today we're moving on to exponential and growth and decay functions. So an exponential function is in the form y equals a b to the x, where a doesn't equal 0, and b is a positive real number other than 1. If it's a growth function, if b is less than 1, so like between 0 and 1, it's a decimal. I mean, it's a decay. It is a decimal, but it's not what I was meaning to say. Okay, so these want me to tell whether each function is a growth or decay, and then graph the function. So if I look at number 1, my base is greater than 1. And I apologize, I forgot my dot camera design. So this one is going to be growth. And it wants me to graph this function, so I am going to go to Desmos. And it looks like this. So I'm going to go sketch that graph. This one is less than 1. So it's going to be decay, and that means the more it goes to the right, the more it goes down. We'll see this once I have this graph. So this one, it starts high and then goes really low. So I can use exponential models to represent real-world quantities that either grow or decrease. Growth model is y equals a times 1 plus r to the t power. And decay is y equals a times 1 minus r. So decay goes down, growth goes up and adds. Thank you. A is the initial value, R is the interest rate as a decimal, T is time in years. So number 1 wants me or tells me the value of a car in thousands of dollars, so this really means $25,000, can be approximated by the model y equals 25 times 0.85t, where t is the number of years since the car was new. I need to say whether the model represents growth or decay. So is this number inside going, is it larger than 1 or is it more than 1? Less, so it's going to be exponential decay. B wants me to find the annual percent increase or decrease in the value of the car. So what I want to do here is I'm going to take 1 because 1 was part of the equation, and then I'm going to subtract 0.85 to figure out what percent change it has. So 1 minus 0.85 gives me what? 0.15. And then, I forgot my one. To turn this back into a percent, what do I have to do? Move the decimal, or I could multiply by 100. Both work, which gives me 15%. Okay. And then it wants me to estimate when the car value will be $8,000. So what I want to do is graph. I wanted to change the color. I want to graph my equation and y equals 8. Because the model was for 8,000. So, I mean, was modeled in thousands. So they cross right here, which is about 7. So about 7 years. Questions here? Okay. This one tells me in 2000 the world population was about 6.09 billion. During the next 13 years, the world population increased by 1.18% each year. It wants me to write an exponential growth model that gives the population in billions rather than, no, why did I say rather? In 2 years after 2000, and then it wants me to estimate the world population in 2005. So the first thing I want to do here is I want to use the growth because it tells me it's going up. So the one I highlighted in yellow. My initial value is 6.09. And then I want to turn this into a decimal. To turn it into a decimal, I divide by 100, which gives me 0.0118. And then my exponent is t for time. So that's the first part, the answer of this question. Then it wants to estimate the world population in 2005. So how many years after 2000 is 2005? 5. So I want to go ahead and plug in 5 for the t right here. Then I want to go ahead and type this into decimals. Which gets me, we're going to go out to 2 decimal places because our original was out to 2 decimal places. So that would be 6.45, or no, 6.46 because after the 5 is a 7, so I round up. To turn it into a decimal, or you can move it to the left. Okay. And then the last one wants me to estimate the year when the population was 7 billion. So I want to graph y equals 7 and the original equation. When I do it in decimals, I need to do x's instead of t's. So if I click on the dot where they cross, it's 11.8, so about 12. So 2012. Question 2. Okay, so number 5, is this growth or decay? Growth. And then when you graph it, it looks kind of like this. Number 6, growth or decay? Okay. And that one looks like, oh, no, that's not the one. Like that. Questions on 5 or 6? Okay, number 7 gives us a car value model. It says y equals 31 times 0.92t, where t is the number of years since the car was new. Is this growth or decay? Decay. And then I want you to find the percent increase or decrease. So what I want to do is I want to take the number inside the parentheses and subtract from 1, which gives me 0.08. Which is 8%. C wants me to estimate when the value of the car will be 9,600. So because it told me the model was in thousands of dollars, I want to take this and divide by 1,000 to get 9.6 that I'm going to be graphing. And then I'm also going to be graphing this equation. So I want to see where these two are crossing, which is right here. That would be 14 years. Number 8 tells me in 2000 the population of a city was 1.04 million. During the next 14 years, the world population increased by about 2.05% each year. It wants me to write the growth model and then estimate the population in 2008. So the first thing I want to do is set this up. It started at 1.04, so this is the A value. This is my R, and as a decimal, it's going to be 0.0205. And I plug in, so it's 1 plus 0.0205. My exponent of t. That is my equation. Then I want to go ahead and find out when the world population was 2008. So for my t value, it's going to be 8 because 2008 is 8 years after 2000. So I want to plug in 8 to this equation. So I go back to decimals. This one is population. So population went out 2 decimal places. So here I'm going to go out 2. It's 1.22 million. And then for the last one, it wants me to estimate the year when the population was 1.3 million. So I'm going to graph y equals 1.3. And then I'm also going to go ahead and graph this. So I want to find where they crossed, which is right here. That's almost exactly 11 if I round up. So 11 years later is 2011. Thank you.